Students, we were discussing about the power factor that is there in the chapter of alternating current, and we have learned a little bit about the power factor. Now we will see that from the DC expression, the power that we write for the DC expression, and we will see that how it is related or how it looks similar to the case of this AC circuits and what relation is being derived after seeing the similarity between the AC circuits as well as the DC circuits. Alright. So students, the power expression that we write for the DC circuits is P equals to VI, isn't it, for the DC circuits? For DC circuits. Okay, and for the AC circuit students, you have seen. So from this similarity, we can see that the product VRMS IRMS is called as the apparent power of the AC circuits, isn't it? The expression for the power factor we have derived. Okay, so clearly we can see that your true power, this true power also we did. What is the value of true power? We can say that true power's value is equal to apparent power into power factor. I'm writing power factor in short. What is this power factor means? Your cos theta power, isn't it? Okay. Okay. So this apparent power is what? This is just the product of VRMS and IRMS. Okay. 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 Now if the voltage and the current are in the same phase, okay, so then your theta will be equal to 0 and your cos theta will be equal to 1. Okay, this is happening when both the voltage and the current are in the same phase, and obviously when they are in the same phase, your theta's value will 0. Okay, and the cos theta will become as usually 1. So in this particular condition, the AC circuit consumes the maximum power. Okay, I'm writing here, that is the first condition, that when the voltage and the current are in phase, so theta's value will become 0 degree, isn't it? And as usually the cos theta's value will be equal to 1 because cos 0 is 1. So for this condition, the AC power, the power that is being consumed by the AC circuit will be the maximum, isn't it? So this is a condition, students, that when we're getting the maximum power. Now what is the condition 2? Okay, that if the voltage and the current are either minus 90 degree or plus 90 degree, that means when they are out of the phase, then your cos theta's value will be equal to 0, and when the cos theta's value is 0, then your p's value will be 0, isn't it? Okay, so I'm writing here that when V and I are out of phase, okay, so then it will be understood. Then we can see that cos theta will be equal to 0 and your p's value will be 0, isn't it? So for this we can say that the AC circuit of this type consumes no power. Understood? So the corresponding current that for this particular condition, that when the V and I are out of the phase, alright, for this condition we can say that the corresponding current for this is referred as the wattless current because your P's value is becoming 0. Okay. Okay. So students, we have nearly covered we have seen that how much power is being consumed in the AC circuits and all. Okay. Now students, we will see that the time interval between the peak values of the voltage and the current. Okay. Yes. So students, the peak value of the voltage and the current expression that we write, that we have discussed in the class, in the offline classes. Now let's just write the equations for V, that is for voltage V equals to V naught sine omega t, and for the current that we write I equals to I naught sine, within bracket, omega t minus theta, isn't it? So when your V is equal to V naught, this is possible when your omega t's value is pi by 2. Okay, so I'm writing here V will be equal to V naught if omega t is equal to pi by 2. That means your sine pi by 2 means what? 1. Sine 90 degrees value is 1. So then only V will be equal to V naught. Okay. That means, in other words, we can say time will be equal to pi by 2 omega. Okay. Similarly, the voltage case we have covered. Now we'll see for the current part. Okay. Similarly, for this current part also we can write I will be equal to I naught when your this part omega t minus theta is equal to pi by 2. Okay. That means your t, let's write it as t dash, students. Okay. T dash will be equal to pi by 2 omega plus theta by omega. This is the maths part. Just you have to find out the value of t dash. No physics is there. Okay. So thus we can see that the minimum time interval between the peak values of AC voltage and the current is what? Let's write it as T naught. That is the minimum time interval between the peak values of voltage and the current is denoted by this T naught is equal to T dash minus T, which is equal to theta by omega. Just to subtract these two equations, equation number 1 and this equation number 2, you will get the value as theta by omega.